Calculate fuel efficiency in kilojoule per gram of C2H4 and C4H10. The heats of formation of C2H4, C4H10, CO2 and H2O are 52.3, minus 126.1, minus 393.5 and minus 285.8 kilojoule per mole respectively. C2H4 undergoes combustion producing CO2 and H2O. Then what is the delta H value or what is the amount of heat evolved? तो उसके लिए इक्वेशन हो जाएगी C2H4 plus 3O2 forming 2CO2 plus 2H2O. Now equation 1 हो गई, equation for the formation of C2H4. Equation 2 is the equation for the formation of C4H10. Equation 3 is the equation for the formation of CO2 and equation 4 is the equation for the formation of H2O. Now equation for the combustion of C2H4 is C2H4 plus 3O2 forming 2CO2 plus 2H2O. तो इस इक्वेशन में हमें 2 moles of CO2 चाहिए प्रोडक्ट साइड में and 2 moles of H2O चाहिए प्रोडक्ट साइड में. So what we will do, we will multiply equation number 3 by 2 and equation number 4 by 2 and we will add these equations and we get the equation 2C plus 2O2 plus 2H2 plus O2 forming 2CO2 plus 2H2O. Now we need C2H4 on the reactant side. So what we will do, we will subtract equation 1 from the sum of 2 times equation 3 and 2 times equation 4. On subtracting, 2C cancelled, 2H2 cancelled, 2O2 and O2. This will be equal to 3O2. अब ये C2H4 जो प्रोडक्ट साइड में है, it has negative sign. तो इसको पॉजिटिव बनाने के लिए we have to shift it to the reactant side. So the equation becomes C2H4 plus 3O2 forming 2CO2 plus 2H2O. तो ये हो गई equation for the combustion of C2H4. Now the delta H values 2 into delta H value of equation 3 plus 2 into delta H value of equation 4 minus delta H value of equation 1 and this is equal to minus 1410.9 kilojoules per mole. Now this delta H value minus 1410.9 kilojoule per mole is the delta H value for the combustion of 1 mole of C2H4 and it gives the fuel efficiency of C2H4 in kilojoules per mole. अब इसको convert करना है kilojoules per gram में. तो 1 mole of C2H4 is equal to its molecular weight which is equal to 28 gram. तो 1 mole of C2H4 कितना heat evolve कर रहा है? So we can say that 28 gram of C2H4 gives minus 1410.9 kilojoules of heat. So 1 gram of C2H4 will give minus 1410.9 divided by 28 which is equal to minus 50.39 kilojoules. So we can say that the fuel efficiency of C2H4 in kilojoules per gram is minus 50.39. Now equation for the combustion of C4H10 will be C4H10 plus 13 by 2 O2 forming 4 moles of CO2 plus 5 moles of H2O. तो हमें चाहिए 4 moles of CO2 product side में and 5 moles of H2O on the product side. Again what we will do, we will multiply equation number 3 by 4 and equation number 4 by 5 and we will add these equations and we get 4C plus 4O2 plus 5H2 plus 5 by 2O2 forming 4CO2 plus 5H2O. Now from this we will subtract equation number 2. Equation 2 is 4C plus 5H2 forming C4H10. On subtracting 4C cancelled, 5H2 cancelled, 4O2 and 5 by 2 O2 will add up and this will be equal to 13 by 2 O2. अब product side में C4H10 है with negative sign. To make it positive, C4H10 will shift to the reactant side. So we get the final equation C4H10 plus 13 by 2 O2 forming 4 CO2 plus 5 H2O. This is the equation for the combustion of C4H10 और इसकी delta H value will give the fuel efficiency of C4H10. तो डेल्टा एच वैल्यू कैसे आएगी? डेल्टा एच वैल्यू हो जाएगी 4 इंटू डेल्टा एच वैल्यू ऑफ इक्वेशन 3 प्लस 5 इंटू डेल्टा एच वैल्यू ऑफ इक्वेशन 4 minus delta H value of equation 2. Just as we have added and subtracted the equations, in the same way we will add and subtract the delta H values. So delta H value for this combustion of C4H10 is minus 2876.9 kilojoule per mole. Again we have to convert it into kilojoule per gram. So 1 mole of C4H10 is equal to how many grams? 58 gram. This is the molecular weight of C4H10. So 58 grams of C4H10 gives minus 2876.9 kilojoules of heat. So 1 gram of C4H10 will give minus 2876.9 divided by 58, which is equal to minus 49.6 kilojoule per gram.